Right now, something impossible is unfolding across the Ring of Fire. On December 8, 2024, two magnitude 6.3 earthquakes struck Alaska's Aleutian Islands within hours of each other. The stress waves rippled outward through the Pacific system. 7 months later, Indonesia's volcanoes erupted in succession. Mount Lewa Tobi Laki-Laki sent ash 11 miles into the sky. Then came the signal no one expected. In Ethiopia, a volcano dormant for 12,000 years exploded back to life on November 23, 2025, hurling ash across 3 continents. 5 major eruptions, dozens of significant earthquakes, and for an entire month stretching into early 2025, not a single magnitude 7 or greater earthquake struck anywhere on Earth. Is this global silence the final warning before something catastrophic? What if the largest earthquakes aren't disappearing, but building towards something far worse? What if every eruption, every tremor, every locked fault is part of a chain reaction scientists can measure but cannot stop? The Pacific system is no longer following predictable patterns. The numbers tell a story geologists have seen only twice before, in the months preceding the deadliest earthquakes of the 21st century. In early December 2024, Alaska's subduction zone convulsed. 2 magnitude 6.3 earthquakes struck southwest of Adak Island within 4 hours. A magnitude 6.1 followed 23 minutes later. The Alaska Earthquake Center called it a swarm, not a typical main shock-aftershock sequence. These were multiple earthquakes of nearly equal magnitude clustering along the plate interface, where the Pacific plate dives beneath the North American plate. The swarm wasn't random. Stress had been building unevenly along that section of the subduction zone for months. When it finally released, the energy didn't dissipate, it transferred. Seismic waves from the Alaska swarm traveled through the Pacific's interconnected fault systems at thousands of kilometers per hour. Within days, seismometers across Indonesia registered new activity. What followed was a cascade that stretched the length of the Ring of Fire. But the real shock came from where the signal traveled next. Scientists have long debated whether earthquakes in one region can trigger events thousands of kilometers away. The USGS maintains that there is no definitive evidence that an eruption at one volcano can directly cause an eruption at a volcano on a different continent. Static stress transfer theory suggests that most triggering effects dissipate within a few hundred kilometers. Yet the pattern emerging across the Ring of Fire in late 2024 and into 2025 challenges this assumption. Alaska's swarm occurred on December 8th. Indonesia's volcanic unrest intensified through the winter. By late spring 2025, Mount Lewa Tobi Laki-Laki was erupting with unprecedented violence. Then on July 7th, 2025, the volcano exploded twice in one day. The second blast sent ash 18 kilometers into the stratosphere. Pyroclastic flows raced 5 kilometers down the flanks. 24 international flights were canceled as the ash cloud drifted across Southeast Asia. 3 weeks later, on July 30th, 2025, Russia's Kamchatka Peninsula buckled under a magnitude 8.8 megathrust earthquake. It was the strongest quake recorded since Japan's 2011 Tohoku disaster. Tsunami warnings stretched across the Pacific from Japan to Chile. Over 2 million people evacuated coastal zones. The waves that reached Hawaii surged more than 5 feet above normal tide levels. The timeline is what alarms geologists. On November 23, 2025, Ethiopia's Hayli Gubbi volcano erupted for the first known time in 12,000 years. The volcano sits in the Afar Depression, part of the East African Rift system where 3 tectonic plates are actively pulling apart. For millennia, Hayli Gubbi had been silent. Geologic records show no eruptions during the entire Holocene epoch, the period spanning the last 11,700 years. Then, without warning, the volcano exploded. Ash climbed 14 kilometers into the sky. The plume drifted across the Red Sea toward Yemen and Oman. By the next day, volcanic ash had reached India and Pakistan, forcing dozens of flight cancellations. Local residents described hearing a sound like a bomb. One witness said it felt like a sudden explosion, with smoke and ash blanketing entire villages. Livestock lost grazing lands overnight. The eruption continued for several hours before subsiding, but the damage to the local economy was immediate. Scientists were caught off guard. Juliet Biggs, an earth scientist at the University of Bristol, noted that satellite data had hinted at possible recent activity, but the scale of the eruption was unprecedented for a shield volcano in that region. Most shield volcanoes produce gentle lava flows, not towering ash columns. The Smithsonian Institution's Global Volcanism Program confirmed that Hayli Gubbi had no known eruptions in the current geologic epoch before this event. The awakening of a 12,000-year dormant volcano is extraordinary on its own. But it occurred in the same year that witnessed 74 confirmed volcanic eruptions from 65 different volcanoes worldwide, with 47 volcanoes remaining in active eruption status as of May 2025. This represents one of the highest active volcano counts in recorded history.
Indonesia's volcanic landscape became the epicenter of the surge. With 120 active volcanoes positioned along the Ring of Fire, Indonesia accounts for nearly one-third of the world's most dangerous peaks. Mount Conleon in the Philippines erupted 4 times between June 2024 and May 2025, displacing over 1,000 people. Mount Semeru produced major pyroclastic flows in late 2024. Mount Ruang erupted continuously through April 2024, forcing evacuations across multiple islands. What connects these eruptions is timing. They occurred within months of each other, clustered along subduction zones where tectonic plates collide. Geologists note that synchronized eruptions across thousands of miles are statistically rare and suggest possible interconnected geological processes operating at depths beyond direct observation. The pattern repeats throughout the Ring of Fire. Japan's Shinmodake volcano produced continuous gas and ash plumes through mid-2025. Ash columns rose up to 5 kilometers above the crater rim. Russia's Kluchevskoye volcano on the Kamchatka Peninsula erupted multiple times. Alaska's Great Sitkin volcano has been erupting continuously since May 2021 with no sign of stopping. Every eruption releases pressure. Every earthquake redistributes stress. But something else is happening beneath the surface. For geologists tracking global seismic patterns, the alarm isn't just the eruptions, it's the silence between them. According to data compiled from the USGS and International Seismic Networks, 2024 recorded only 99 earthquakes exceeding magnitude 6.0, the lowest annual count since 1982. More significantly, there were no earthquakes of magnitude 8.0 or greater for the 3rd consecutive year. This marks the longest period without a major megathrust earthquake in modern seismic monitoring history. The quietest month came in early 2025, when for 30 consecutive days, not a single earthquake of magnitude 7.0 or greater occurred anywhere on Earth. To seismologists, this is not a sign of safety. It is a warning. Earth normally releases tectonic stress through thousands of small and moderate earthquakes each year. These events prevent strain from accumulating to catastrophic levels. When moderate earthquakes stop, it means something is locked. Faults that should be slipping are instead holding, and every day of silence adds energy to the system. The pattern is called a seismic gap, and it precedes the largest earthquakes in recorded history. Before the 2004 Sumatra earthquake, a magnitude 9.1 event that killed over 230,000 people, the Sunda Trench went quiet. GPS stations detected slow uplift along the coast, indicating the plates were locked. Then the rupture came, tearing along 1,300 kilometers of fault line in less than 10 minutes. Before the 2011 Tohoku earthquake in Japan, seismologists measured declining B values, a statistical indicator that tracks the ratio of small earthquakes to large ones. When B values drop, it signals that a fault system is accumulating strain. The Tohoku quake reached magnitude 9.0 and generated a tsunami that killed over 18,000 people. Now, in late 2025, multiple fault systems around the Pacific are showing the same warning signs. Tectonic plates are not smooth surfaces. They are fractured, rough, and covered in irregularities that create friction. When 2 plates try to slide past each other, they often jam. The leading edge of the descending plate catches on the overriding plate. Stress builds. The rock bends but does not break. Years pass. Decades. Centuries. This is called elastic strain accumulation. Think of it as a rubber band stretched tighter and tighter. The longer the fault remains locked, the more energy it stores. Eventually, the friction fails. The plates lurch forward. The rubber band snaps, and the ground releases centuries of stored energy in seconds. The physics are unforgiving. A fault locked for 300 years will produce a far larger earthquake than one that slips every 50 years. The Cascadia subduction zone, which runs from Northern California to Vancouver Island, last ruptured on January 26, 1700. It has now been locked for 324 years. Geologists know this because of evidence preserved in Japan. Japanese historical records describe a tsunami that struck the coast on January 26, 1700, with no associated earthquake felt in Japan. By analyzing the tsunami's size and timing, scientists traced it back to a magnitude 9.0 earthquake in the Pacific Northwest. Tree rings from drowned forests along the coast confirmed the date. The land subsided suddenly, drowning coastal forests in saltwater. Ghost forests still stand beneath the water of Lake Washington. The next Cascadia earthquake is not a question of if, but when. Around the Pacific, seismologists are tracking multiple indicators that suggest the quiet period may be ending. B values are declining along several major subduction zones. These statistical measures show that the ratio of small earthquakes to large ones is shifting. Fewer small quakes and stable medium-sized quakes suggest that stress is building toward a major release. Slow slip events, which are episodes where tectonic plates move incrementally without generating earthquakes, have decreased along the Cascadia and Nankai Trough subduction zones. These slow slips normally help release strain gradually. When they stop, strain accumulates faster. GPS measurements show increased crustal deformation along the Pacific coast from Chile to Alaska. Land is rising in some areas and sinking in others, indicating that the plates are bending under stress. In some locations, the deformation rates have increased by 40% compared to decade-long averages.
These patterns match the conditions observed before both the 2004 Sumatra and 2011 Tohoku earthquakes, but this time the signals are appearing simultaneously across multiple fault systems, not just one. The global scope of the current seismic quiet is unprecedented. Never before have so many major subduction zones shown coordinated signs of strain accumulation within the same time frame. Scientists are exploring whether volcanic eruptions themselves can alter stress conditions on nearby or distant faults. When magma rises through the crust, it displaces rock and changes pressure distribution across fault networks. In some cases, this can destabilize locked sections of a fault. Research on volcanic triggering remains speculative. The mechanisms are complex and not fully understood, but the correlation is undeniable. Periods of intense volcanic activity along the Ring of Fire have historically coincided with clusters of major earthquakes. The theory suggests that rising magma creates pressure gradients that propagate through interconnected fault systems. Even if a volcano is hundreds of kilometers from a major subduction zone, the stress changes it generates can travel through the crust. When multiple volcanoes erupt simultaneously, the cumulative effect may be enough to tip a locked fault toward failure. Whether this is happening now cannot be confirmed, but the timing raises questions scientists cannot ignore. 3 fault systems stand out as the most dangerous. The Cascadia subduction zone stretches for 700 miles off the coast of the Pacific Northwest. It is capable of producing a magnitude 9.0 earthquake comparable to the Tohoku disaster. Recent mapping by researchers at Columbia University revealed that a segment of the fault from southern Vancouver Island through Washington State is markedly flatter and smoother than previously thought. This geometry is associated with the largest megathrust earthquakes globally. The fault has been locked for 324 years. Geological evidence shows that Cascadia typically ruptures every 400 to 600 years, though intervals have ranged from 200 to over 1,000. The southern end of the fault is more active and has a 40% probability of producing a magnitude 8.0 or greater earthquake within the next 50 years. When Cascadia ruptures, it will generate minutes of intense ground shaking across the Pacific Northwest. Coastal areas will experience sudden land subsidence of 1 to 2 meters, raising relative sea levels permanently. A tsunami will strike the coast within minutes, with wave heights potentially exceeding 20 meters in some locations. The Oregon Resilience Plan estimates fatalities could range from 650 to 5,000, with total economic losses exceeding $32 billion. The Philippine Sea Plate system is building strain in a pattern eerily similar to Cascadia. GPS data show accelerating crustal deformation along the Manila Trench and Philippine Trench. Both are capable of generating magnitude 8.5 or greater earthquakes. The dense population in Manila and surrounding provinces places tens of millions of people at risk. Japan's Nankai Trough is arguably the most closely monitored subduction zone on Earth. It produced massive earthquakes in 1944 and 1946. Researchers estimate there is a 70 to 80% probability of a magnitude 8.0 or greater earthquake along the Nankai Trough within the next 30 years. On August 8, 2024, a magnitude 7.1 earthquake struck the Huguenota region, part of the Nankai system. The event triggered a slow slip episode detected by GPS stations along the coast. Japanese officials issued tsunami advisories and conducted nationwide emergency drills. The three fault systems are interconnected only by the physics that govern them, but if one ruptures, the stress redistribution could bring others closer to failure. Current earthquake early warning systems can provide seconds of advance notice, not minutes or hours. Shake Alert, the system deployed along the West Coast, detects the initial P waves of an earthquake and sends alerts before the more damaging S waves arrive. In practice, this gives people between 5 and 30 seconds to take cover. 30 seconds is enough to drop, cover, and hold. It is not enough to evacuate coastal zones before a tsunami arrives. For communities along the Pacific Northwest coast, a Cascadia earthquake will generate a tsunami that reaches shore in 15 to 20 minutes. Evacuation must happen before the shaking stops, while roads are still passable and people can still move. In remote coastal areas of Alaska, Washington, and Oregon, evacuation routes are limited. Some communities have no high ground within walking distance. Vertical evacuation towers have been built in a few locations, but coverage is incomplete. For thousands of people, there is no safe refuge within reach. In Japan, tsunami warning systems are among the most advanced in the world. Even there, the 2011 tsunami arrived faster than many expected, overtopping seawalls and flooding areas previously thought safe. The Fukushima Daiichi nuclear disaster resulted from the tsunami's impact on critical infrastructure. No amount of early warning can eliminate the danger when the fault is close to shore. Maria Santos checks her emergency kit every Sunday. She lives in Newport, Oregon, within the tsunami inundation zone. Her house sits 3 blocks from the beach. When the earthquake comes, she knows she has 15 minutes. Her kit contains water, food, first aid supplies, a hand crank radio, and copies of important documents sealed in waterproof bags. She has marked the evacuation route on a map taped to her refrigerator. The route leads uphill to the high school, which sits above the projected tsunami zone. She has drilled the route with her 2 children. They know which streets to take, where the bottlenecks will be, and what to do if they get separated. At night, she leaves shoes by each bed so they can run without stopping to dress. Everyone says it might not happen in our lifetime, but I've read the reports. 300 years is a long time to wait.
Earthquake drills are routine in Newport. Schools practice drop, cover, and hold monthly. But Maria knows the drill assumes buildings will stand. If the shaking lasts 4 or 5 minutes as predicted, many older structures will fail. The high school might not be standing when they arrive. She has started looking at property inland, outside the inundation zone. But housing prices have made it impossible. So she checks her kit every Sunday and hopes the scientists are wrong. Predicting the exact timing of a megathrust earthquake remains beyond current scientific capability. Tectonic processes operate on timescales that span centuries. Even with advanced monitoring, researchers cannot determine whether a locked fault will fail tomorrow or 50 years from now. What they can say is that the conditions for a major earthquake are present. Stress has accumulated to levels historically associated with catastrophic ruptures. The longer the silence continues, the larger the eventual release will be. But earthquakes are chaotic systems, influenced by countless variables below the threshold of measurement. Some geologists argue that the current clustering of volcanic eruptions and seismic quiet may be coincidental. Earth's systems are complex. Correlation does not prove causation. Without a clear physical mechanism linking volcanic activity to earthquake triggering across thousands of kilometers, the connection remains speculative. Others point to the statistical improbability: 74 volcanic eruptions in 1 year, the longest period without a magnitude 8.0 earthquake in modern history. Simultaneous strain accumulation across multiple fault systems. The odds of these patterns occurring independently are vanishingly small. The debate will continue. But while scientists argue over mechanisms, the evidence accumulates. What cannot be disputed is the current state of the Pacific system. 5 major volcanic eruptions have occurred along the Ring of Fire since late 2024. A volcano dormant for 12,000 years has reawakened. Earthquake frequencies have dropped to historic lows. Major subduction zones showed declining slow-slip activity and increasing crustal deformation. GPS data confirm strain accumulation at rates exceeding normal variability. The pattern matches conditions observed before the 2 deadliest earthquakes of the 21st century. This time, the warning signs are not confined to one region. They span the entire Pacific. The Cascadia subduction zone has been locked for 324 years. The Nankai Trough is building toward another rupture. The Philippine Sea play system shows accelerating deformation. All 3 are capable of generating magnitude 9.0 earthquakes. All 3 could rupture within a compressed time frame, each event redistributing stress and bringing neighboring faults closer to failure. If one megathrust fault ruptures, the cascade could begin. Stress waves traveling through the crust could destabilize faults already near their failure threshold. The resulting earthquakes could trigger additional volcanic eruptions, which in turn could further alter stress conditions across the region. This is not certainty. It is possibility, grounded in physics and pattern recognition. But the stakes are measured in millions of lives. The next weeks and months will reveal whether the current seismic quiet is a temporary fluctuation or the final buildup to an event that could rewrite geological history. Scientists will continue monitoring GPS deformation, seismic activity, and volcanic gas emissions. Emergency management agencies will update evacuation plans and conduct drills. Individuals will decide whether to prepare or to hope. The Ring of Fire is not passive. It is a dynamic system under immense strain, and systems under strain eventually break. Will the next earthquake be the one that changes everything?